and kind of what it means and why it's super critical. The So I know I started a class by talking about there are certain things in JavaScript that you can just like if you don't like how they're used, or if you find them confusing, or for whatever reason you don't want to use them, you can avoid using them, right, and use another way to kind of by proxy get to the same end result. This is not one of them. Pass by reference versus pass by value is built into JavaScript, and this will be there no matter whether or not you want to use it. So it's not something you can avoid. And so because of that, if something about this doesn't make sense, like definitely let me know, and I'll do my best to clarify as much as I can, because this is going to be persistent in almost every piece of JavaScript that you ever write. So make sure you actually understand what's going on. Okay, so today we're going to do a quick recap on primitive versus complex types. And then we're going to talk about variable assignment, which will then help us understand kind of how that feeds into this idea of passing values, assigning values, and why pass by value versus pass by reference are actually pretty confusing, but very vital topics in programming in general, really. So a quick recap of primitive versus complex values, right? Primitive values, those are the main types in JavaScript. And really what defines a primitive value is the fact that you can't change a primitive value, right? A 4 in JavaScript is always going to be a 4. You can add 1 to it, and then you're now referring to a 5, but the 4 is still always going to be a 4, right? A string is always going to be a string. You can't ever change a string. You can create a new string. You can take out each letter. You can remove certain letters. You can create a new variation of a string. But once you make a string, like that particular value is fixed. And so for any value whose value we can't change, we call it a primitive. We contrast that with things that we call complex values. So these are objects and arrays, I guess, and also functions. But let's just talk about objects and arrays for now, right? With an object and an array, I can change like that value, right? If I have an array of 2 things, I can add this third thing to the array, right? And at that point, I'm not creating a new array. I'm actually just adding something to my existing array, right? Same thing with an object. If I have an object with 1 key value pair and I add another key value pair, I'm not creating a new object. I'm literally just changing my original object, right? And so because it is changeable, because it is what we call mutable, they're considered complex values in JavaScript. So the complex values are objects, arrays, and functions. There might be a few more, but those are by far the biggest ones that you need to be aware of. So if I have 2 strings here, right? On line 2, I have this variable called British city, and I set equal to the value of York. And then on line 3, I have American city. I set equal to British city. If I reset the value of American city and I say equals new space plus American city, if I console log out British city and I console log out American city, I get York and New York. Okay, so I guess like the main thing here to just know that like, hey, on line 2 I set British city equal to York. I never really changed British city, so when I console log it up here on line 7, I still get York, right? Up there. For American city, I set that equal to British city, but then when I add another string to it, here I'm not changing the American city string, I'm just adding a new string to it, right? Where I'm really changing it is here where I'm actually saying, hey American city, I'm going to send you to a brand new value. So the way that I actually like drawing out this section probably a little bit more because I think it's something that makes more sense visually. Right? So imagine I have a line in the middle. Not that one. Let's say this is my variable, and this is my value. Okay. Okay. So on one hand, if I have something, I'll just call it BC, British city. BC is my variable, right? And it's pointing to a value, and this value is a string called York. Okay. York can never be changed, right? this York value can never be changed. And so on line 2, when I define this, I create this. On line 3, what I'm saying is, hey, let's create a variable called American city. I set it equal to British city, right? And what I'm doing is, I am actually also setting it equal to a string called York. Okay? Does this make sense so far? Okay. So here on line 5, what I'm actually saying is, on line 5, what I do is I evaluate the right-hand side of the equality first and try to figure out what this equals, right? And it's this string new plus this string called American city. Remember what the plus operator does. It returns back, when I try to add strings to it, what it does is it's not necessarily just combining these two strings, it's giving me a brand new string. That is, the result allows me to join these two strings together, right? So what the plus operator is doing is, the plus operator is actually creating this brand new string called u space York here, right? And then I'm saying, hey, American city, the variable, why don't you set yourself to equal this new value now? And so what I'm doing here is I'm actually erasing this arrow and drawing the arrow here. Okay? That's why when I print out British city, it's giving me York, but when I print out American city, it's giving me new space York. Okay? The two things here are to know that, like, by redrawing the arrow for American city, I did not impact British city at all. Right? British city is what it was. And then secondly is, I didn't change this York string. I created a brand new string called new York, and then I pointed the variable to it. And so this is why I did the printout I see on the far right. Are you feeling good? Okay. Awesome. So as you can probably tell, like, this is something that's, this is probably not going to hold true on the case, right? Otherwise we wouldn't have this lesson here. So if I kind of undo this now again, and I undo the arrows, now let's see what happens when my value is no longer a primitive, but it's a complex value. In this case, I'm setting it equal to an array. Okay. BC is British city, and on line 2, I'm setting it equal to an array with a string called York. Okay. I set this equal to this. Because, and so on line 3 then, I'm creating this new variable called American city, AC, and I'm setting equal to British city, okay? Here's where the distinction between the two types, well, one of the ways in which the distinction between two types kind of manifests itself, right? When York was just a string, I knew that string was never going to change, right? It was always going to be York. So I felt very comfortable making a copy of York and saying, hey, you know what? When I refer to you, I'll see what your current value is, and what I'm going to do is I'm going to make a copy of that, because I know that what I have and what you have must always hold true. Does that make sense? Like, if I know that your value is going to be York, and this York is never going to change, then I'll just say, let me get my own version of York, right? With an array, that's not the case. If I make my own here for American City, if I say, all right, great, that sounds good, let me do what I did before, let me make my own array of York. If I change this York, if I change this array, now these two variables are out of sync, right? And remember, I am able to change this value, right? When this was only a string, I couldn't change it. It was immutable. I couldn't change that string, so I had no problem making a copy of it. Here, this is an array. And by definition, an array is able to be changed. And so the problem here is, if I make my own copy of the array, they could potentially be out of sync if I change one array and not the other. So in order to bypass that, because these two things are changeable, what happens is this American city variable now also points to the same array. Everything on the right-hand side you can think about as existing as, like, you have a computer, right? The computer has memory, right? It might have like a byte address or like a memory stamp. This is kind of the value that's being held in the computer computer's memory for that address. And so now, we have two variables that both point to that same exact value. And so that's why here on line 5, when I do American City.unshift new, I go to American City and I say, hey, whatever value you have, I'm going to assume it's changeable, and I'm going to add new to the front of it. So now I delete this, and I add new as the first variable, and then York now becomes my second variable. But notice how British City was also pointing to the same thing earlier, right? So now when I change American City, I'm also changing British City. And that's why here on line 7 through 8, when I print these two out, I get New York, because by definition they have to be equal. Because if I draw the arrows out, they are pointing to the same exact thing. Yes? Makes sense? If you understand this slide, then this is pretty much it. This is like the TLDR version of this entire topic. When we talk about pass by value versus pass by reference, pass by value means, hey, I'm going to give you what the value of this is, right? And usually we use, not usually, we use pass by value when we talk about primitives, right? I'm comfortable with you giving me the value of this thing because I know this thing can never change, right? When we say pass by reference, what we're really saying is, hey, give me not the value of it, because I know the value can be changed. Give me the reference to the memory where this value is located. Because I know that even if you add wherever you want here, this is going to still occupy, theoretically, the same space in memory. And so as long as I know where this is in the computer's memory, the value could change, but I know where to start looking. And so when we say pass by value versus pass by reference, pass by value is used in instances in which we know the value is fixed, so primitive data types. Pass by reference is when we know the value is able to be changed, so therefore we need a reference to the memory space. That's what the reference means. So a pass by reference is used for the non-primitive data types. Okay. So on this slide, what we're really doing is, so this kind of gives you a really quick, actually I'll just draw this out. They're drawing out down there too, but I'll just kind of walk through it as well. This kind of gives you a more granular step-by-step breakdown. I know right now, so far, you probably use an equal sign, the sign operator, pretty fluidly. You just kind of assume that it works. But we just want to make sure you understand kind of what's going on behind the scenes, right? On line 4 here, if I was a computer and I was evaluating this page of code, on line 4 here, the first thing I'm doing is I'm saying, okay, I'm going to create this variable called first, okay? And then there's going to be a value of 20. Is 20 primitive or non-primitive? It's primitive, right? It's a number. It's a primitive, and 20 will always be 20. I can't change that. And so after line 4, what I have is I have this relationship. I have a variable called first, I have a value called 20. Okay? And first is referring to 20. Cool. Then on line 5, what I'm doing is I'm saying, hey, create a value called 30 and repoint first towards 30. So I say, okay, great. First is now pointing towards 30. Everyone's good so far, so? Now when I say, hey computer, what's first? Computer will go to first, it'll say, oh, yeah, this is pointing to the 30 value, so therefore you are now 30. On line 7, what I'm doing is I'm creating this variable called second, and I'm setting it equal to 30. But notice how, even though they're both 30, these two are actually unrelated, right? Remember, 30 is just a number, right? Like I can't ever change 30. So everyone's gonna have like their own value of 30, right? It's the same way like, I use analogy too much, but like if I buy a car and you buy the same make and model of the car, it doesn't mean we have the same physical car, right? We happen to have two different copies of the same car, right? That's what the concept is here. So here we have two 30s, right? They're not the same thing. They're two different things that happen to have the same value, right? And so on line 7 there, we're creating a second variable. We're saying, well, 30 is a primitive value, or it's just a value. Happens to equal this, but it's still its own value. Let's draw this line here. And then line 8, what line 8 is doing is, line 8 is doing plus plus, but what that really does is it basically creates this new value called 31, and then redraws the arrow from second to 31. So now when I console log out first and I console log out second, I get 30 and 31. Well, all right. So if we ratchet up the complexity just a little bit, then. All right. Okay. By the way, can we see the board? Do I need to tilt the board? Okay. So here on line 1, we go back to our 20, and first is still that. Great. But now on line 2, what we're saying is second is equal to first. Okay, second is equal to first. Do I draw the arrow like this? Why not? It's a copy, right? 20 is a number. 20 is a primitive. For primitives, we do pass by value. And so what I don't necessarily care where in memory this 20 is. I just gotta say, give me a value of 20, right? So what second is going to do is second is going to create its own copy of 20. And now look at that. There's no connection between first and second, right? First is pointing to its own 20. Second is pointing to its own 20. And therefore on line 4, when we do, oh, by the way, can we increment 20 to 21 and reassign second to it? That's great. Second is now pointing to 21. And when we console log out first and second, we never reassign first ever, right? First has always been pretty consistent. It's like I'm 20, and now second is saying I'm 21, right? Even in the middle, when we print out second, even though they're printing out the same numerical value, they each have their own copy of 20. So even at that point, they kind of lose this. They kind of lost this connection to each other. However, if we do. Hold up. 10, 20. Okay, yeah. I won't draw this one. This is just showing you like how to add something to an array. But when we talk about something a little bit more complex here, okay. So this one, I'm also not going to draw out because I think most people this is just kind of like the car analogy I just made, right? The two variables first and second, even though the thing they're setting to has the same quote-unquote value, like they're clearly two different copies, right? Like if I have let x equals the string David and let y equals the string David, they might have the same value, but they're clearly different, right? In this case, first and second, even though we're talking about a complex data type, this is an array, this is an array. This is 10, 20, this is 10, 20, this is 10, 20, this is 20. Yeah, they have the same value right now, but like they're clearly like not related to each other. They just happen to have the same value at the moment. And so when I add the number 30 to the second one, it doesn't change the first one, right? Because first never had any association with second. They were always different. They just happen to have the same values at that moment in time. So this one I think most folks understand pretty conceptually, but this is the one that I'll draw out now. Okay. Okay, so for first, we have an array, and it's 10, comma, 20. Okay? Now, on line 3, we're saying, hey, let second equal to first. So now, we're going to draw this arrow to for second. I draw it to this one, right? Because what I basically need to see is, okay, what kind of value is first? First is an array. Is an array changeable? Yes. So I need access to that particular array, right? Because I'm trying to measure up to that particular array. If this array changes and I'm pointing somewhere else, I'll never know that it changed, right? If I point to this array, if someone changes this array, great, I'll know that, right? I'll pick up the next time someone needs to ask me what this value is. And so on line 3, we create a second variable and we're pointing to first. And because first is actually an array, we're going to point to the actual same array. And so notice down here, we're actually pointing to the same reference in memory for that array, right? This array is stored, usually what happens here is you store kind of like the beginning of the array. This memory space may not be the entire array, but it's where the array starts. And so we point to here so that we both know where to start looking if we're going to look for this value, right? So here, first and second are both pointing to the same exact reference, which then obviously I may have two cars with the same, make and model, right? But if I give you two addresses and the same address, that's pretty much the same place, right? We're not going to have two copies of the same address in the same city. So therefore, we have two references to the same reference in memory, which means we're actually looking at the same exact value. So now on line 7 there, I just blocked it. On line 7 now, when I push 30 into second, I go to second, I see where it is, I push 30 into it, and voila, I've also now changed first. Because once again, because they're sharing the same space and memory, whatever I do to first will impact whatever happens to second. Cool. All right. Any questions about that? We're gonna do some additional details, but that was by far the most important part of this. Does that make sense? Yeah. When you're doing the problems tonight, if ever you get confused, draw out that diagram. It actually helps a lot. A lot of times in your head, the arrow, you might be I'm confused about where this goes and where this goes. And if you just draw arrows and you draw it sequentially, almost the way a computer would, you're guaranteed to be able to kind of mimic how a computer works. And once again, right, computers are really terrible at ambiguity. They're really good with precision, and so as simple precision as possible, right? So binary is always the best way to go. And so if you're able to kind of think like a computer would interpret that and draw that diagram, then you're always going to get to kind of how the computer is going to evaluate what a given variable, what a given value is. Okay, so so now because of this, hopefully we're now seeing one of the values of our old friend, the slice method on the array, right? I know when we first talked about arrays, I said what slice does is it creates a copy of the array. And I know, we talked about how, modifying the original array is very dangerous. Why would we not want to do it? And so this is another reason why you don't want to modify necessarily the original array, right? Is because not only is that original variable pointing to that array, but other variables could be pointing to that array as well. And you actually don't know who else is pointing to it. So if you change it, you're not changing it just for that variable. You could be changing it for other variables too. It becomes almost like a global variable at that point. And so, what I'm saying makes sense. Continue. So I guess I'll just kind of go a little bit overboard here, right? Let's say first is equal to this array, right? 1, 2, and then I say second is equal to first. If I do down here, if I do first dot push, right? It's going to change this, but it's also going to change the variable second as well. But if I look at just this line, I have no idea second also got affected. So this is one of the reasons why dot slice is really helpful, right? If I have an array called first and it's equal to an array with a value of 10, 20. When I do array.slice there on line 3, what I'm doing is I'm actually going to create a brand new copy of that array. And notice how if I create a separate copy of that array, I get the same quote-unquote value of it, but it's a copy, right? It exists in a different place of memory. So I can do whatever I want to this array, and it has no bearing on the previous array. That's pretty much it. So that slice just creates a brand new copy of the array. So when we talk about, passing values is synonymous with using values. So, passing values in terms of assignment is pretty common. What else is pretty common? Doing something like this, right? Passing a value into a function. Same idea. We're taking a variable and we're saying, hey, take this variable that was created here and use it somewhere else, right? When we pass a variable into a function, everything we talked about still applies. Remember, what we're talking about here is global, right? It will always be in JavaScript, whether it's not something that you use, it's something that exists, and you kind of have to deal with it. Kind of like gravity, right? Like, you can't just say, I don't believe in gravity. It's like, no, gravity believes in you, I guess. Or how do I say it? But it's like this will always be there, right? So when I pass in a variable into a function, I need to be very clear. Is this a primitive value or is this a complex value? If I pass in a primitive value like I am doing here, right, my num is equal to 10. So when I pass in my num here, and this becomes num, is this a copy of my num or is this a reference to my num? It's a copy, right? Because 10 is a number, so when I pass this 10 here into this function, I'm passing in a copy of the 10. And so here I say, hey, you remember the 10 that you had? Why don't you add 20 into it and return num? Well, guess what? My num never changes, right? Because my num is primitive. Whatever was passed in here was a copy of the value of 10, which is 10. I add 20 to it, and I spit back out 30, right? But my num, once again, never gets changed. In fact, it's not possible to change this thing unless you use the equal sign to reassign this variable to another value. You will never change this 10. You have to change whatever it's pointing to point to a different value, right? It's the same way how it's like, it's here is my num, and this is equal to 10. Once I draw that arrow, the only way to change my num is to draw that arrow and point it to something else, right? This 10 can never be changed. That's why it's primitive. Similarly, if then we do the converse of that, which is we pass in an array. Well, now we're actually passing in like a reference to the original array, right? My array is an array with one thing. If I pass my array to this pushes 20 function, well, guess what's going to happen? I'm going to push it in. I'm pass in an array. I'm going to add 20 to it. I'm going to return the array. So this array here, it's not just a copy of this array. It is that array, right? They're both pointing to the same space in memory, that thing. So when I add 20 to it, I actually am adding 20 in both cases to both the original, or I'm adding 20 into the actual like memory where that array exists. So whatever's pointing to it, they all get that same change. There.
So if you wanted to do that and not change my array, you would slice my array and put that into the function.
Exactly. Yep. Yep. Okay. So I think on Tuesday, I also had another group. They were using the triple equal signs to compare two arrays or two objects or whatever it was, and they were like, hey, these arrays clearly have the same value, but they're not equal. Why is that? And the reason why is because for complex values in JavaScript, the triple equal signs will compare it based on reference, not by the actual value, right? So the analogy here is that like they care whether or not like the address is the same, not whether or not you have two copies of the same car. Right. So even if you have two arrays that both have a numbers 1, 2, 3, in JavaScript land, they're not equal. And the way JavaScript determines that is pretty simple. They'll go to the first variable and say, hey, which space in memory are you referring to? And they'll go to the second variable and say, what space in memory are you referring to? And if those memory references are not the same, they're not equal. Nothing else matters. With a number, with the primitives, like it's very different, right? Then you're comparing the actual values. But for complex values, when you use triple equals, you're only comparing the references in memory. That's why these two will never be equal, but this one is. Cool? Does it make sense still? Yeah, Andre?
If you use like double equals for back compare values, or that's just like.
Yeah, I actually don't know, but I'll say never use double equals. So I'm sure we can find out pretty easily, but this is also the kind of thing where you don't want to do that necessarily. Like, you know how like we had you write a pretty complex, not complex, but like, we had you write a function to compare two objects. Like that's what you should be doing as opposed to kind of try to use double equals to get a proxy for it. Okay, cool. And then lastly, array.slice. The last thing I'll talk about .slice. The last thing I'll talk about .slice is this idea of a shallow copy versus a deep copy. So let's say I have two variables, x and I have y. Okay. If x is equal to, let's do 1, 2, 3, and I create a copy of x. So let's say I do x slice and y is equal to x slice. Okay. Y is now equal to an array of 1, 2, 3. Right. I go through every single value. They're all primitives. I copy the value. I put it in an array, and now there's nothing. There's a blank line here, right? There's a gap. Nothing is tying these two. Nothing is tying x to y. They're completely separate, right? This is what we consider a shallow copy. And what I mean by shallow is the fact that notice how, like, with the world I just described, what I do is I go through this array, and for every single value, I check to see if it's a complex or to see if it's a primitive or a complex value. If it's a primitive, I make a copy of it. But what if this was a complex value? What if this next thing was an object as opposed to a number? Now what happens? Well, what I just described holds true, right? I go through every single thing, and if it's a primitive, I make a copy of it. If it's a complex thing, I actually make a reference to it. And so in this array, if this last object is a complex, so in this case, if it's an empty object, when I do x.slice, what actually happens is this empty object, almost like part of the drawing here, but almost gets shared between these two arrays. And this is dangerous because now, guess what? Notice how there's no more gap anymore, right? Whatever I do to the object in x is going to impact y. But only what I do to this object. Notice how if I add another number to the end of this, that's totally cool, right? But I now have this tie, which is this object. So when we talk about shallow copy, it's this idea that, like, hey, we go through it once, and for every value we see, if it's a primitive, we make a copy of it. If it's a complex value, we make a reference to it. Now, the way that we want to be doing this, technically speaking, is something called the converse of a shallow copy is a deep copy, right? And a deep copy is a world in which we actually go through this, and for every primitive value, we actually we return a copy of it, but for every complex value, we then call a dot slice on that as well. Essentially a dot slice on that as well, right? So here we're calling a dot slice on this outer array, but let's say the inside here, let's say this was an inner array. We will call dot slice on this too. And we will keep calling dot slice until we get to a world in which everything's only primitives. Right? So that's what we call a deep copy. A deep copy is any copy of a deep result will always be a copy that has absolutely no connection to the original. A shallow copy is a copy that will have a connection to the original if any of the elements are complex values, as opposed to primitive values. Right? So if I was making a deep copy of this in order to dot slice, I would go to 1 and copy 1, go to 2 and copy 2, go to 3 and copy 3, get to the array and say, great, let's slice this array as well. So I create a new empty array, and I say this has a number in it called 4. I will then say, oh great, there's only one value there, so 4 is a primitive. I'll just copy the value of 4, and now I'm done. If there was another array inside of there, I would call dot slice. I would call dot slice again and again and again until I reach a point in which there's only primitives in that array. And so we'll learn how to do this, and we talk about the recursion section of this. And in most cases, a shallow copy will kind of get the job done. But it's just to kind of let you be aware of that dot slice is not like a panacea. You can't just call dot slice on every single array and assume that there'll be no more connections to the original. Okay. Any questions? Yeah.
How do you check if it's a deep or shallow copy if you don't know if there are objects in the original?
That's a good question. And the short answer is you can't unless you want to go through and actually check it. So what you want to do is you want to do a dot slice, but you also want to go through the elements and check to see if there's any types or objects.
Or functions.
Or functions, right? Or functions. Yeah, those are the two things. So. There might be something built in that does deep copies for you. I'm sure like some of us may want, if they're having, you probably just copy it pretty easily, but conceptually this is the difference between a deep copy and a shallow copy. So. All right, any questions? Yeah.
One more. So if you wanna copy array, you can slice it. What about objects and methods? Is there something like slice for them?
Yeah, there is. For objects, there's something called object.assign, and you'll quick Google. If you just Google how to copy objects JavaScript, like it's the first thing that comes up. And same for functions. Although off the top of my head, I don't know what the function is called to copy a function, but like it's doable. Yeah. At least let me check that on you. How to copy functions JavaScript. Oh. Stack Overflow. Oh, function.clone. Makes sense. Is this, or actually no, wait, did they write that themselves, or function that equals this, temp equals function temporary return that apply, that is, oh, okay, yeah, this is complicated. So you definitely will need, there is a way to do it, but you won't need to do it, but there is a way, but it's just a little bit more complex than I thought. So it won't be as something as simple as object.assign, but it looks like there is a way to. Yeah. Oh god. Oh, okay. Oh, that's pretty cool. So what you do is you actually change it into a string and then you reparse it back out again? What? That's so weird. Okay. Anywho, a kind of a detour. You don't need to know how to do it, but if you ever need to, Google's your best friend. Okay. So, any questions here?